For years we've been talking to AI through chatbots, but what if AI could do more than just talk? What if it could actually act on its own, learn from its mistakes, and solve really complex problems out in the world? Well, that is the promise of AI agents, and a brand new research paper called Agent-R1 just gave us a powerful blueprint for building them. So let's break down exactly what makes this new approach such a big deal.
All right, so here's the plan. We're going to walk through how we get from a simple chatbot to these powerful agents. We'll look at the huge puzzle researchers have been stuck on, the clever new rulebook they wrote to solve it, and the incredible results from their training system, Agent-R1. And then we'll talk about what this all means for the future.
So let's set the stage. The big dream for large language models, LLMs, is for them to grow up, to go beyond just spitting out text and become active, autonomous agents that can actually do things in the world. And this visual really nails the difference. See, on the one hand, you have these simple workflows where a person has to map out every single step. But on the other, you have a true agent. It's not just following a script. It is in this constant loop of trying something, getting feedback from the world, and then deciding what to do next. It's dynamic, it's proactive.
And this really gets to the heart of it. We're not just trying to build a better search engine here. The real mission is to create an AI that can actually think for itself, take action, learn from what happens, and get smarter over time. I mean, this is a huge leap towards a more general problem-solving kind of intelligence. Okay, so how in the world do you teach an AI to do all that? Well, the key is supposed to be this technique called reinforcement learning, or RL, which is all about learning from trial and error. But here's the puzzle. Trying to apply RL to these super complex LLM agents has been, well, incredibly hard.
The researchers behind Agent-R1 said it perfectly in their paper. They basically admit that, yeah, RL is the right tool for the job, but nobody's really figured out how to use it right in this new, complex, agentic world. It's kind of like having a jet engine, but no manual on how to install it.
And the challenges here are pretty serious. The training can be super unstable. Sometimes it just completely fails. Figuring out how to reward the AI for taking good steps is a total nightmare. And a lot of times, the agents just can't generalize what they've learned, or they freak out when the environment does something unexpected. So it was obvious a totally new approach was needed.
And this is where the Agent-R1 paper gets just brilliant. Instead of trying to jam a square peg into a round hole with old methods, the researchers went all the way back to square one. They decided to rewrite the fundamental rules of the game for how an AI agent even makes a decision.
Now that rulebook is called a Markov Decision Process, or MDP. Don't worry about the jargon. Just think of it as the basic operating system for any decision-making agent. It defines everything, what the agent knows, what it can do, and how it gets points. The real genius here is how they updated this classic framework for a modern AI agent.
And this table just lays out the breakthrough perfectly. They expanded every single piece of the MDP. For a chatbot, the state is just the text on the screen. For an agent, the state is the entire history of everything it's done and all the feedback it's gotten. A chatbot's action is just picking the next word, but an agent's action can be a command to use a tool like searching the web. The transition is no longer predictable because the world can throw curveballs. And finally, the reward. A chatbot gets one big grade at the end. An agent gets rewarded for good steps along the way. They call these process rewards, which is a much, much better way to learn.
Let's put it even more simply. A chatbot, it has short-term memory, it follows the script, and it gets graded on one single final exam. An Agent-R1 agent has long-term memory, makes its own choices, and gets graded with little quizzes all along the way. I mean, which one sounds like a smarter way to learn? So the big takeaway is that by rewriting these rules, they built a foundation for agents that can learn in a much more dynamic and, frankly, realistic way.
So, with this new rulebook in hand, the team actually built a framework to train these agents, and they call it Agent-R1. This is the training ground, the gym, where these new, smarter agents get made.
And you can see the process right here. The agent gets an instruction. It thinks. It takes an action. Maybe uses a tool. The environment gives it some feedback. The agent thinks about that feedback, and the whole loop starts over, again and again. Each one of these cycles is a complete learning experience.
The system itself is so elegantly designed. You've got two main parts. First is the tool. Think of this as the hands, the action taker. It could be a web search, a calculator, whatever. Its only job is to do its thing and report back exactly what happened. Then you have the tool environment. This is the brain, the judge, and the scorekeeper.
It takes the raw result from the tool, decides what it all means for the task, updates the agent's worldview, and hands out the rewards. The really smart thing here is that it's modular. You can easily swap in new tools and new scoring rules, which makes the whole thing incredibly flexible.
Okay, so the theory is smart, the system looks great, but does it actually work? This is where we get to the results, and honestly, they're really impressive. The team tested their agents on a super hard task, answering questions that require multiple steps of thinking and searching.
And just look at this chart. On the left, you've got the performance of the old methods sitting at around 0.13. On the right, you have the agents trained with Agent-R1. Their best one scored a 0.38. That's not a small bump. That is a massive leap in performance. It's a total game changer.
In fact, let's put a hard number on it. The paper points out that even the weakest agent they trained with their new system still performed about 2.5 times better than the absolute best of the old methods. The takeaway is just undeniable. This new training blueprint isn't some minor tweak, it's a fundamental breakthrough that dramatically boosts how well these agents can perform.
So what's the secret sauce? Well, it comes down to a couple of really clever tricks for precision learning. First, there's the loss mask. This tells the AI to only learn from the words it generates, its own thoughts and actions, and to ignore everything else. It's like only grading a student on their own written answers, not the question itself. Second is the advantage mask. This is a super sophisticated way to assign credit. In a long chain of actions, it pinpoints exactly which decision led to a good or bad result, which makes the learning signal incredibly sharp and effective.
All right, so let's zoom out and bring this all home. This research is way more than just some academic paper. It is a foundational step that connects directly to the future of AI in our world. So what does a technology that lets us actually train autonomous agents unlock? Well, we're talking about hyper-competent personal assistants that don't just find information, but complete complex, multi-step tasks for you. We're talking about AI agents that could help with autonomous scientific discovery, or systems that can evolve on their own to get better at solving problems. This is the toolkit for building more robust, more adaptable AI that we can trust with truly complex stuff.
And this leaves us with a really fascinating final thought. For the first time, we have a clear, effective blueprint for teaching an AI to learn from its own actions and its interactions with the world. So the question really isn't if we can build these agents anymore, it's what we should do with them. What is the first great, complex problem that we should ask them to solve?